Okay, so in the world of mobile development, accessibility plays a crucial role in ensuring that everyone, regardless of their physical or cognitive abilities, can effectively use and interact with digital applications. My name is Pavlo Dzhus. I am Android developer at mBank. Today we'll dive deep into the often overlooked role of accessibility in mobile app development. We'll explore innovative techniques and tools to ensure that your apps are inclusive for users with disabilities. We'll discover how to create truly universal experiences that cater to a wider audience. So let's start with the question, why apps should be accessible? To increase your app's reach. According to the World Health Organization, an estimated 1.3 billion people experience some kind of a disability. This represents 16% of world's population, or 1 in 6 of us. Quite huge numbers and a market share. According to APPT, more than a half of Android and iOS users surveyed have one or more accessibility settings activated on their phone. People with disabilities depend on apps and services that support accessibility to communicate, learn, and work. By making your app accessible, you can reach these users. To improve your app versatility. Accessibility features benefit all users. By making the app accessible to people with disabilities, we automatically make it more usable for everyone. For example, if someone is using your app while they cook, they can use voice commands instead of touch gestures to navigate. Low vision features make apps useful in bright sunshine. Providing accessibility means also caring for users who use mobile devices with small screens or slow internet. To meet ethical, government, and institutional requirements. Think of accessibility as treating everyone fairly, giving them the same chances no matter their abilities. We shouldn't exclude someone from entering a building because they use a wheelchair. So we also shouldn't exclude someone from an app because of low or no vision. Modern buildings should have elevators and ramps. Modern apps should support screen readers and scalable texts. Making your app accessible to people with disabilities demonstrates a genuine commitment to inclusivity and social responsibility. When companies prioritize accessibility, they show that they value all users and understand the diverse needs of their customer base. The thoughtful approach not only builds trust and credibility, but also enhances the company's reputation as an ethical and forward-thinking organization. Accessibility goes beyond mere convenience as well. It's a matter of equity, opportunity, inclusion, and legal compliance. In many countries, this is already regulated by laws, and many of them require all products used by government employees to be accessible. Companies are following suit. So, the importance of accessibility in mobile apps. Before talking about accessibility, we need to talk about disability. A disability refers to any condition of body or mind that makes it more difficult for a person to engage in certain activities and interact with the world around them. Disabilities can affect various aspects of life, including vision, movement, thinking, and so on. Although people with disabilities are sometimes referred to as a single population, this is actually a diverse group of people with a wide range of needs. Two people with the same type of disability can be affected in different ways. Some disabilities may be hidden or not easy to see. Accessibility, often abbreviated as ALI, refers to a design of products, services, and environments in a way that enables their use by people with disabilities. While technology often simplifies tasks for most users, for people with disabilities, technology can be a powerful enabler, turning the impossible into possible. Accessibility ensures that content, services, and apps are designed to be usable by everyone, regardless of their physical or cognitive abilities. In short, disability refers to limitation in interacting with the environment, and accessibility is about removing those limitations. Yet, despite the clear importance of accessibility, The majority of mobile apps and websites are still not fully accessible. Most fail to meet even basic accessibility standards. For example, in 2023 analysis by WebAIM found that 95.9% of top 1 million websites did not conform the web accessibility guidelines, the most widely used global standard for web accessibility. This means that only about 4% of the internet is fully accessible to people with disabilities. Common uses include low contrast text, missing alternative text for images, and empty buttons. The Web Content Accessibility Guidelines serve as internationally recognized standard for ensuring digital accessibility. They cover a broad spectrum of disabilities, including sensory, intellectual, learning, and physical, and aim to make websites, apps, and digital content more inclusive. While WCAG isn't a legal requirement, there are legal acts to protect the rights of individuals with disabilities. For instance, the European Accessibility Act, which sets EU-wide accessibility requirements for products and services applying to both public and private sectors. Beginning in June 2025, most business websites and apps must comply with the standards. Failing to address accessibility not only excludes millions of potential users, but also open businesses to a significant legal and financial risks. The number of web accessibility lawsuits has increased in the recent years, with about 4,000 lawsuits filed in 2023, which representing a 42% increase over 2022. For businesses, the cost of inaccessibility go beyond lawsuits. A 2021 study estimated that the average cost of web accessibility lawsuits is about $100,000. However, the economic benefits of accessibility are clear. The same study found that large companies could realize a 3-year profit of $77,000 simply by making their content more accessible for people with hearing or visual impairments. And when we consider the entire spectrum of disabilities, the potential gains even greater. Globally, 1.3 billion people, about 60% of our world's population, live with a disability. In the European Union alone, 27% of adults, or about 100 million people, are disabled, representing enormous purchasing power. According to Return of Disability report, when you include friends and family, people with disabilities control over $30 trillion of annual income. Neglecting accessibility doesn't just exclude potential customers, it risks significant revenue loss. People with disabilities often shop online more frequently than average customers, meaning businesses that fail to make their apps accessible are likely losing out on market share. Designing for accessibility benefits everyone. It drives innovation, making apps more user-friendly and efficient, and creates better digital experience for all users. Companies that prioritize accessibility enhance their brand, attract new customers, and build loyalty among existing ones by demonstrating their commitment to diversity and inclusion. That's why it's crucial to integrate accessibility from the beginning. To do this effectively, we need a solid understanding how accessibility works. Let's start by asking fundamental question. How do people originally use their phones? Users typically interact with the device by performing actions like taps or swipes, and the smartphone responds by displaying the information on the screen. For individuals with disabilities, the process can look different, but the principle remains the same. They send commands and receive information from the device, just through different methods. For example, they may use voice commands, external input devices, and other assistive technologies. The method may vary, but the goal is identical: to interact with the smartphone seamlessly. To make this possible, platforms like Android often built-in accessibility services such as TalkBack, Switch Access, and Voice Access. These tools serve as essential plugins that empower users with disabilities to navigate and interact with the devices effectively. Through tools like screen readers, adaptive keyboards, and voice inputs, people with disabilities can engage more independently with technology in ways tailored to their specific needs. However, developing mobile apps that meet these accessibility standards come with unique challenges. Mobile apps need to support a wide range of disabilities, each with distinct requirements. Let's focus on the primary challenges faced when designing apps for users with visual, auditory, motor, and cognitive impairments. For users with visual impairments, whether particularly sighted or completely blind, screen readers, high contrast displays, and text scaling are essential tools for app navigation. However, common accessibility barriers still exist, such as poor color contrast, not descriptive buttons, and the absence of accessible alternative for visual content. So here's how we can address these issues. Ensure the app is compatible with screen readers like TalkBack. So this means properly labeling UI components, buttons, and images using content descriptions. Use high contrast color schemes to improve readability. Avoid flashing elements. Allow users to scale text size and ensure UI elements set up dynamically. Provide meaningful text description for all visual content. For users who are deaf or hard of hearing, relying solely on sound-based interaction or notification can present significant barriers. Missed audio signals or media content without text alternatives can result in critical information gaps. To overcome these challenges, provide captions for all multimedia content. Replace sound-based notification with some haptic feedback or visuals, and for any sound-based notification or media, provide corresponding text-based information. Users with motor impairments often struggle with small touch targets, complex gestures, or touch-only navigation. These barriers can make it difficult for them to interact with apps that require precise motor control. To enhance accessibility for motor impaired users, ensure buttons and touch targets are large enough to be easily selected. Avoid requiring multi-finger gestures or complex swipes for critical actions. Ensure that all app functionality can be accessed via keyboard and support compatibility with external assistive tools like switches, adaptive devices, and so on. For users with cognitive disabilities, complex workflows, inconsistent navigation patterns, and information overload can lead to frustration and confusion. This can particularly affect users with memory issues, learning disabilities, or attention disorders. Here's how we can make apps more accessible for users with cognitive impairments. Use clear, concise language in instruction labels and descriptions. Maintain consistency in design elements and interaction patterns throughout the app. Break down complex processes into smaller, manageable steps, and avoid clutter screens by organizing information in clear, logical order. Provide clear error messaging and help users recover from mistakes easily by offering undo operation or context-specific guidance. While these strategies often theoretical solution, the real impact lies on their practical application. So how do we move from guidelines to practice? Let's figure out how to make an app more accessible with a few simple steps. They will cover up to 90% of all possible cases. I will show you mostly examples for Android, but the good news is that all components in Android and iOS standard library support accessibility by default. You won't have to figure out and make basic components accessible from the scratch. The modifier semantics usually specify semantics information about the component. What component is, what is done to it, and what its state is. Modifier.semantics and modifier.clear and set semantics is created to clear semantics from the child composables and overload it. Composables and modifiers can indicate that they want to merge that semantics by setting merge descendants property to true. Vue in Android has three main semantics parameters: content description, state description, and the role. Android evolves, so do the ways of building UIs, but content description remains. It should be specified for images or complex components. Let's be honest, we all set the content description to null, but because why should I need it? But if you want your application to be accessible, you have to set this field unless this icon is used for decorative purposes and does not represent a meaningful action for users can take. Any clickable elements on the screen should be at least 48 by 48 dp. This size is recommended by Google. The clickable area on the screen is approximately this value. On iOS, for example, recommended size is 44 by 44 points. Note that both dimensions have to be at least 48 or 44, not just one. It's crucial to make the touch targets big enough for effortless tapping, ensuring designful user experience. And we must add some spacing between those touch areas, preventing missteps. Remember, this is not for nibble finger folks but also for those with limited mobility who deserve a frustration-free interaction. The clickable modifier attempts to expand such composables. It will succeed only if there is enough space in the parent composable in all needed directions. The Compose standard library provides a modifier ensuring the smallest accessible touch area. You may use a minimum interactive component size for that. In the case of toggleable elements with labels, the entire area should be clickable. People with visual impairments may perceive colors differently. It's a good idea to make sure that all elements on the screen are clearly distinguishable from each other, and there is a color contrast. It's good practice to set color contrast on overlapping components to a ratio of more than 3:1 for large text and 4.5:1 for everything else. You can check the color contrast between colors at WebAIM. The higher the contrast, the better readability. Larger font sizes also require a lower minimum contrast for same readability. Large text can have a lower contrast ratio. The minimum contrast ratio doesn't apply to logotypes. Decorative elements like random letters in the background are also out of scope. Keep in mind that people with visual or that people with vision impairments may see worse than you. There are various kinds of intensities of color blindness. So see how affected people may see traffic lights, for example. You can simulate the color vision deficiencies on Android devices through the setting. Dark mode is a display setting where the background is dark, often black or dark gray, instead of traditional light of color scheme. Although one may think that dark mode is a matter of style of UX, it can also improve accessibility. Dark mode reduces the exposure to a blue light. It can assist in elevating digital eye strain, also known as computer vision syndrome. It may occur due to extended periods of screen usage. In a nutshell, you need a second color palette. In Jetpack Compose, you can use is system in a dark theme function. It returns true if a dark mode is currently on. There is no defined smallest font size in WCAG guidelines, but there are various third-party recommendations. Android Lint has a small DP jack. It allows sizes down to 11 SP. Adobe recommendation is at least 40 SP with absolute minimum of 12 SP. The rule is simple. Always specify font size in scale pixels. You might ask me, why do they have to be separate units for fonts? If I specify size in DP, no one will die. If users enlarge font in the system, they need to enlarge them in the application as well. This is what the SP unit is for. If you use SP unit, the font size will scale automatically. According to WCAG resize text guidelines, users should be able to resize text up to 200%. Of course, this should be achieved without any loss of content or functionality. You can use preview annotation to check in Android Studio. for example, to simulate 200% font scale. What can go wrong when font scale is large? The text simply can be too long. It can be cut off, wrapped, or overlapped with other elements. There is no universal solution for all cases. The most accessible option is to always show the entire text, even if it's occupying the largest screen space. In XML, we used to use text all caps parameter to make text all caps, but thank goodness there is no such a parameter in Compose. On some devices, screen reader reads text written in capital letters as an abbreviation, letter by letter. As you understand, it's very difficult to perceive it by ear. Only abbreviation should be capitalized. The main text should be written in lowercase or sentence case. The heading is the title of a section. It describes the content below. TalkBack provides convenient navigation between headings. If there is a lot of text with heading on the screen, for example, there is a list of sublists that are also labeled with headings, you need to assign to the header semantics to it. WCAG has several guidelines related to headings. In the case of website, there are 6 headers. In Android apps, we have only 1. The heading often corresponds to the headline text styles. Choose the number of headings wisely. Too many of them may clutter the navigation. Too less, on the other hand, can make it difficult for users to find the desired part of your app. There usually has to be at least 1 heading on each screen. Sometimes you need to update the value on the component that is not in focus when you act on one component on the screen. For this purpose, Jetpack Compose has a parameter that can be set inside the semantics block modifier that allows you to read the value from the view if it has been changed. It doesn't matter if it's currently focused or not. To interrupt ongoing speech, also known as being assertive, use live region mode assertive. To wait for ongoing speech, also known as being polite, use live region mode .polite. The WCAG guidelines say that all functionality should have be accessible from the keyboard. Nowadays, smartphones usually don't have a physical keyboard, but they do have a virtual one. You can also connect one with Bluetooth or USB OTG. The TalkBack screen readers also act as a keyboard. What's more, the users can navigate with a D-pad or a stick on wired and wireless controllers. To ensure that the app is usable when the user navigates with such keystrokes, you have to check the focus order. Ideally, the order should go from left to right, from top to bottom, but sometimes this order has to be changed for more convenient navigation between components. In most cases, it works out of the box, so you don't have to do anything. There are some exceptions, so sometimes you have to change the default focus order by using focus requester or traversal. Unlike the view system, accessibility support in Compose is a bit more limited. You can no longer set any string in order field, only one of the predefined ones. You can't track accessibility events in components. For example, you now can't intercept events via accessibility delegate. There is no analog to view component and announce for accessibility in Compose. These are main features are fine. There are probably more things that Compose is missing. These changes weren't made for no reason. Using the functionality incorrectly could confuse users, and developers might accidentally create problems for themselves. Google has done a great job in developing Jetpack Compose. Now it's much easier to make an application accessible. No need to use scary entities like accessibility delegate compat and overload with methods in that delegate. The approach is simpler. Write code as usual and it works. The main recommendation, accessibility improvement should be minimal. There is no need to reinvent the wheel. The remaining tools should cover the whole scope of possible problems. Once development is complete, accessibility testing is a crucial step to ensure your application is accessible for all users, including those with disabilities. Testing for accessibility provides invaluable insights by allowing you to experience the app from the app's perspective and knowing potential usability issues that might otherwise go unnoticed. To achieve comprehensive results, it's essential to combine multiple testing approaches. Manual testing, so just interact with the app by using Android accessibility services. User testing, gather feedback from the users. Analysis tools, just leverage automated tools to uncover areas for improvement. Automatic testing, for example, Compose UI Test Kit or Espresso. Manual testing allows you to step into the shoes of your users interacting with your app through accessibility service to simulate their experience. To do so, you should open your device settings and navigate to accessibility to explore how users can adjust their device's settings greater functionality. Depending on manufacturer of your phone, the content on screen may vary, but in any case, you can install the missing components. Let's take a look on the available options. Android provides several solutions for users with visual impairments. For example, TalkBack, a screen reader that vocalizes UI elements, within text, icons, actions, and alert sound. Select to speak, lookout, which using the device camera and recognizes objects and text in the environment, and some other. For users with hearing impairments, Android offers live transcribe, live caption, sound amplifier, and hearing aid support. For users with motor impairments, Android provides switch access, which allows users to control the device using external switches, and voice access, which provides hands-free control over the device through voice commands. Android also includes tools to assist users with cognitive impairments. Project Relate, which tailored to individuals with speech disorders. This app learns the unique speech patterns and helps to improve communication. And some action blocks that enables users to create customizable buttons for routine actions, simplifying tasks such as making a call or controlling smart home devices. By using manual testing and exploring accessibility services, you can gain a deeper understanding of how users interact with your app. You can read more about this feature on the official documentation. Let's see one key accessibility service, TalkBack, a screen reader that provides users with visual impairments essential auditory feedback. Once TalkBack is on, there are two common ways to navigate. Linear navigation, which is quickly swiping left-right to navigate through screen elements on the sequence, double tap anywhere to select the current screen element, and explore by tapping. Drag your finger over the screen to hear what's under your finger. Double tap anywhere to select the current element. To streamline testing, Android provides developer-specific settings for TalkBack, like TalkBack shortcut, log output level, and display speech output, which is the most useful one. Manual testing is irreplaceable, but automated tools like Accessibility Scanner app can help you detect around 40 to 50% of potential issues. Accessibility Scanner scans your app for elements such as missing or incomplete component labels, inadequate touch target sizes, clickable elements without proper description, and poor contrast between text and background. These tools also offer fixes for some of the detected issues and providing additional information about them. However, it does not catch all accessibility problems. so it cannot guarantee full accessibility for your app. Manual testing is still necessary. The great thing is that you can use an accessibility scanner with any Android app, whatever it's native Android app or built with cross-platform technologies like Flutter or Kotlin multi-platform. You can even use it with progressive web applications. But even without a scanner, you can find out how accessibility friendly your user UI is. The Android accessibility test framework is integrated in Android Studio to help you find accessibility issues in layouts. The IDE itself will tell you which element has what problem. It will even give you a link to the documentation. Also, you can activate Compose UI check mode on Compose Preview to enable Android Studio to automatically audit your Compose UI for accessibility issues. Android Studio checks that your UI works across different screen sizes by highlighting issues such as text stretched, or large screens, or low color contrast in the problems panel. There are also possibility to verify correctness and prevent regressions by using automated UI tests. As we look towards the future, artificial intelligence is set to play a transformative role in making mobile apps and digital platforms in general more accessible to users with disabilities. AI is being used to bridge gaps that were once difficult to address through traditional design and development methods, bringing intelligent, adaptive solutions that enhance user experience in a way never before. So how exactly can AI improve accessibility? Let's explore some of the key areas where AI is already making a difference. One of AI's most significant contribution to accessibility is automatic captioning for videos and real-time transcription of audio content. This innovation is especially beneficial for users who are deaf or hard-hearing. Services like Google's Live Caption use AI to provide on-the-fly captions for any media playing on the device. These AI-driven solutions ensure that content is more accessible, saving developers the effort of manually creating captions for each media file. For users with visual impairments, AI-powered image recognition tools are revolutionizing the way they interact with digital content. AI models can analyze images and automatically generate descriptive text, which can then be read aloud by screen readers. This feature brings an entirely new level of accessibility to visual elements, helping blind or low-vision users experience apps in ways that were previously impossible. Tools like Google Cloud Vision are already empowering developers to close the accessibility gap in visual-rich content. For users with speech impairments, AI advancements in speech recognition and natural language processing are particularly valuable. In case where verbal communication is difficult, AI also could help nonverbal cues or offer alternative input methods, making it easier for individuals with speaking disabilities to engage with apps. AI could be integrated for accessibility testing workflows, helping developers ensure that their mobile apps meet accessibility standards more effectively. Instead of relying solely on manual testing or static tools, AI models could predict potential accessibility issues by analyzing user interactions and app behavior. This could allow developers to catch problems earlier in the development cycle, reducing the risk of releasing inaccessible features and improving overall app quality. AI's contribution to accessibility benefits people of all abilities, helping them navigate apps and digital content more effectively. Whatever its automatic caption, image description, voice assistance, or smarter accessibility testing, AI is making it easier for developers to create apps that work for everyone. As developers, we have a critical responsibility to ensure digital platforms are accessible from the start. In a world where mobile devices are an integral part of daily life, apps must be designed and tested to be as inclusive as possible. Prioritizing accessibility isn't just the right thing to do. It also makes good business sense. Accessibility apps can reach a broader audience, and the more inclusive your app is, the larger your potential user base. Accessibility should be woven into every stage of our app development, from the initial design phase to the final testing and even post-launch updates. Gathering feedback from people with disabilities through the process is essential to ensure that your product truly meets the standards. The goal is to make your app intuitive, efficient, and understandable for everyone, without any exception. If accessibility isn't considered during design and development, the risk of failure is high. However, incorporating accessibility principles doesn't require a radical redesign. In most cases, it's about fine-tuning the small details that make a big difference for users with disabilities. Ensuring that your app is accessible gives you the opportunity to see it from a new perspective, improve its overall quality, and create seamless experience for all users. Practicing accessibility design and development is not just a moral obligation, it's also a legal requirement, especially for those building apps for government organizations or large institutions. By making accessibility a priority, you can ensure that your apps should comply with the regulation while also providing an exceptional experience for all users. In conclusion, AI is playing a key role in shaping the future of accessibility, but the responsibility lies with us, the developers and designers, to integrate these advancements into our apps and systems. By doing so, we can help create a digital world where no one is left behind, regardless of their abilities. Let's continue to push for inclusivity, ensure that our mobile apps are accessible, user-friendly, and empowering for everyone. Thank you.